All right, gents, just want to talk to you about system diagrams and how to represent them in a bit of more of an interesting, dynamic, engaging way, opposed to what we've done historically and what's evident in the historical folders. So I want to just use your heating system at home as an example of a system diagram where, first of all, what you have is an input, and that's your thermostat. Your thermostat takes a reading of the heat. If it is below a particular level, it then tells the boiler to turn on, doesn't it? You've got the boiler, turns on, that heats the water, and then you get the hot water going around your radiators. And that hot water circles around the radiators until, of course, there's a point where that heats up the air in your house to such temperature that the thermostat takes a reading and it tells the boiler to turn off. And so this is like a circular system, which is obviously familiar to all of you. So using one of your products as an example, I just want to have a little think about how we can represent this. I've done a little bit of work already on it, but let's use Theo's mug temperature sensor as an example. And we're going to start off just by looking at the different inputs, and we're going to look at the process, and we're going to look at the outputs. Now, all sorts of things fall into that bracket of processes, from transistors to 555, 4017s to 4026s, and also the Genie chips, of course. The Genie chips have different number of inputs and outputs, and therefore, if we know the number of inputs, we know the particular Genie chip we're going to use. Of course, we've got to know the number of outputs as well. Both the inputs and outputs are going to affect the Genie chips. Let's do those first. Inputs. Let's think about a product where what we're going to do is we're going to switch it on. So if we're going to switch this product on of Theo's, we're going to have a single pole, single throw. Okay, so that's it. Flick it on. Then the product is on, but we don't want it on all the time, do we? We want to start the program. So I think we need some sort of push to make. Some sort of push to make that when pressed, the Genie program starts, and then it starts calculating the heat and turning that into some sort of output. And of course, when I say calculate the heat, we're talking about a thermistor as well, aren't we? Now, I think it'd be pretty cool if, in regards to the outputs, we had a light to show it's on. So why don't we go for that? And put an LED down here, and if it's on, sort of green makes sense to me. Then another LED, I think, would be a red LED to show it's too hot. That seems to be an obvious thing to do. I don't know about ready to drink. It's sort of green, maybe another green LED, 2 green LEDs, or blue or something. What about an orange, just to keep them all different? And then to say that it's too cold and you've missed the boat and your tea now is too cold to drink, a buzzer. So we've got 4 outputs, 3 inputs. Genie 8 has got 2 inputs, 3 outputs. That's not going to do it. Genie 14, I think it's got 4 and 5. Oh, I might have 5 and 6, but I'm pretty sure a Genie 14 is going to be absolutely adequate. So this is what we've got, yeah? And if we were going to do this as lines, of course, we've got single throw, and then that go up to your green LED. We start the program, so we should put that down as 1, 2. Start the program on the Genie, and if it was really hot liquid, the red light will come on. No, start it on the program. Genie waits to receive a signal. If the signal is really high, red light comes on. The signal goes down. It turns that off, doesn't it? And then the orange one will come on. If it goes down again, it would turn that one off, and then the buzzer would sound. So what does this look like in your project? That's what you want to know. Well, I reckon it looks something like this, where you draw a series of boxes and each one represents either the inputs or the outputs. And in the middle here, we have the process. So your inputs are your single pass, single throw, your push PTM, and your thermistor. So what's the first thing that happens? As I said, on and off. Okay, once that's happened, what are we looking for? Green light goes on. Show it's on. Fine. Then what? It's waiting for the PTM to be pressed. That starts it up. When that's pressed, really, your genie's waiting for a signal from the thermistor. And this will give you a value, the thermistor gives you a value between 0 and 255, because that's the analog value, 256 different values. Okay, so it's waiting to receive that value. If it doesn't get a value, nothing will happen. But if it gets a value between 201 to 255, for argument's sake, the red light comes on. If the value is between 101 and 200, the orange light comes on. I suppose what we could have put here, and those other two are off, other two are off. And if it gets a value between 0 and 100, then the buzzer comes on, and then the orange and the red are off. Okay, so that's getting my head around how the product is going to work. And what I've done for each one of these steps, I've just put a little bullet point down here. So 1, flip your switch, turn product on. 2, green LED comes on, show product is active. 3, PTM is pressed to activate program/product. 4, thermistor senses heat and sends genie reading between 0 and 255. If reading is above 201, red light comes on. If reading is between 101, 200, orange light comes on. I should have really here put, and the other two are off, but I didn't think about that at the time. And then 7 would be the buzzer. So this is what I would like for you to produce. And I think you could do this quite neatly on a half piece of A4 and include that in your study. Now, you have done a number of different circuit diagrams, so designs for your circuit. I think each one of those designs needs one of these to show how your circuit is becoming more complex and really the initial design of that circuit. So it isn't just about you going on Circuit Wizard, it's about you thinking about the design before you start. Look, guys, I hope this helps, and you can take something from this. I would expect to see 3 of these in your study when it's finished to complement your 3 different circuit designs. All right, cheers.